how to prepare tables and graphs, and with the applications of an SPSS. Then I conclude with the summary. Okay. Quantitative data analysis, whenever we will say that on, of course, it is deals with the numbers, and we have to extract the insight. Means what is the real meaning? What is the real answer, or a real numerical information? Okay, what it means. This is the done by application of an SPSS. Before going for that one, we will see that on data analysis. Okay, yeah, it is a process. First, we have to edit it, we have to cleaning, changing, and processing data and extracting actionable and relevant information that help researchers to make informed decisions. Okay, always keep in mind that one. It has to give an informed decisions, means you have to take in decisions depending upon the validity of the data. So the analysis and interpretation of data with a view toward objective evaluation of the reliability of the conclusions based on the data. This is the main concept of an data analysis. So when you go for a data analysis, okay, in research, okay, why you have to go for it? For the making the interpretation, okay, data driven decision making. How you conceptualize, okay, how you will enter, what type of a test you will use, then you will get the results. Okay, what it means. So quantitative analysis enables research to make informed and evidence-based decisions by relying on factual data rather than intuition or an assumptions. This is the importance of an quantitative research. And you can find out, okay, you have seen that one from the data, what is the changes that have occurred, okay, what is the trends, whether it is in positive trend or negative trend, okay, then we will come to know that what is the deeper insight, the real meaning in the form of an numbers. Next, it gives to accuracy and reliability, okay, of the findings, because we are going for the evidence-based statistical packages. There are so many types of data analysis are there. You can go for, as usual, we have to go for whichever the data is there, first as a descriptive analysis, just to describe it, okay, for understanding the data. Otherwise, we will not come to know like an data distribution, okay. Next, central tendency, data dispersion. Next, we can go for an inferential statistics. This is very, very important for hypothesis testing, whether you have to accept it or you have to reject it, okay. The null hypothesis, whether it is in true or false. Next is the exploratory analysis, to find out patterns, okay, how the changes are there and what is the relationship between the data, between an independent variable, dependent variable, and other types of variables. So to explore it, to know that, okay, to identify correlations or create predictive models, okay, means whether it is positively related or negatively related, or there is no correlation between the two variables or in multiple variables. On the time, we have to go for an exploratory analysis. Predictive analysis, to make in predictions, okay, for future outcomes, just to have a modeling, okay, or think that from the samples you have to predict that whether it occurs or not, okay. Prescriptive analysis used to suggest best courses of action, okay, you can do it. These are the types of data analysis. So I told you that it is a process. First and foremost is to, we have to gather the data from different tools, okay, from an interviews or in questionnaires or in this one. We have to collect the sources, okay, what from case studies, surveys, interviews, questionnaires, or observation. Then you have to clean it, the data. Directly you can do it, or manually also, if it's there, if something, okay, that an outliers or an if something left out, you have to fill it, okay. Data analysis, you can use different softwares like an Excel, Python, or Looker, RapidMiner, Chatio, Metabase, okay, Metabase, Rhituraj, and Microsoft Power BI if it is in business analytics, okay. Or also for, as usual, SPSS is the best software. Data then is the includes as a data interpretation. Whatever the results you get, we have to interpret it, because SPSS will give in the tables, but what it means in your study, okay, according to your objectives and according to your hypothesis, this has to be, and also in research design, keeping it in mind, you have to interpret it. Next, we have to visualize, okay, data visualization. We have to show it graphically to understand it more comprehensively. So when you will go for a statistical analysis, first is the descriptive analysis, like an measures of a central tendency, like a mean, median, mode. It comes as a measures of a dispersion, like an range, variance, especially standard deviation, okay, and other things. For an inferential statistics is the, I told you that one, you have to test the hypothesis. And we need a confidence intervals, okay, because it gives a range of values, okay, how in the, whether it is it meets the true population parameter is likely to fall in the bell-shaped curve or not, okay. Next is the regression analysis. We'll go to know that on the relationship between dependent and other variables, okay, how it is related. Next, probability distributions, like a normal distribution, it is a bell-shaped curve. Binomial distribution means whether it is a fixed number of an independent, whether it follows the Bernoulli styles or not, okay. Next is the position distribution. Models the number of events occurring in a fixed interval of a time or in space, okay, is known as a Poisson. This also can be done. Next is the statistical models. You can go for a linear regression if you want to see the relationship between a dependent variable and more independent variable, okay. On the time, you can go for a linear regression, logistic regression. Whenever the dependent variable is in binary, means two possible outcomes are there. On the time, you can go for logistic regression. Usually, we'll go for an ANOVA, means analysis of an variance, multiple ANOVA. Okay, depending upon the group means how many are there and the items are there. Okay, whether in the group or into the group. Next, we have to consider the sampling techniques matters a lot for going for a quantitative analysis. Okay, you have to have a random sampling. When random sampling is there, there is an equal chance of being selected from the population. So it gives an homogeneity. Next is the stratified sampling, dividing population into subgroups and then randomly selecting the samples. You know that one, it is in stratified. Cluster sampling, dividing the population into clusters, then randomly selecting them. Next is the data collection methods by different methods like in surveys, experiments, questionnaires, observational studies. Otherwise, also, if you are using a mixed methods, okay, of a data collection, you can use it. Okay. Data cleaning and pre-processing, you have to clean it. You have to handle the data, okay, that whether it fulfills all the criteria or not, okay. If any outliers are there, you have to see that one, you have to come to know that one, whether it is really is there or not. And then we have to transform the variables. Next, you can use the softwares like an R, Python, okay, SPSS, SAS, okay, especially SPSS. Next comes as an interpretation and reporting. We have to interpret, okay, whatever the results are there in a very, very meaningful way and also in statistical terminologies. Drawing conclusions and making recommendations based on the analysis. So this is all it includes as an data analysis, okay. So how we have to go for what FFN data, especially if the problem requires the data to be just to summarize and just to analyze it, okay, you can go for descriptive. If you want to test an hypothesis, okay, if the problem requires to an inference to be made, okay, if you want to derive the conclusion, okay, or an inference, on the time you need an inference statistics to explore it, okay. If the problem requires the data to be classified or pattern determined to explore in depth, you can go for an exploratory statistics. The basic things is an mean, mode, median, interquartile range, and standard deviation as a statistical measure. Okay, you know that a mean is the sum of a total divided by number of data values. You can calculate total, then you can divide it by the total number. Okay. Next is the median. Median is the you have to arrange the items in an ascending or descending order. Then you can go for median as the middle one. Okay. Yeah, n by 12 or an n by 2 plus 1 as can be taken if it's an odd. Next one is the mode. Mode is the very frequently, okay, maximum which are all the things the item is in occurring, okay, it's known as a mode. You can calculate by this m naught equals to L naught plus lambda 1 divided by lambda 1 plus lambda 2 into C, okay. Usually it is an grouped data is there, okay. It is an L naught is the lower limit, C is the class interval, data is the difference between modal frequency and also difference between class frequency, okay. So we can go for a mode, which is the maximum which occurs. Next is the interquartile range. Interquartile range is a type of a dispersion being equal to the difference between 75th and 25th percentiles, okay. It is Q3 minus Q1. So we can calculate if it is on 30, 20 items are there. Q1, n plus 1 divided by 4 is the 25th one. Then third one, Q3 quartile, okay, is the 55. So when you minus if when you do, it is the quartile, okay, it comes as a 30. Very widely used is the standard deviation, because this is the essence we what you call for both for descriptive as an inferential statistics we need a standard deviation used to measure the amount of variation or dispersion in a set of values. Okay, how it is dispersed, how the values are dispersed. Of course, it's the fundamental one. It sets for the mean of the data. So standard deviation is usually noted by sigma. Underscore root of 1 minus divided by n minus 1 sigma xi minus x into whole square. Okay. Otherwise, also you can use the down formula. If it is in 10, 20, 30, 40, okay, your numbers are there. When you calculate it manually, you can put the numbers, okay, then you can find out a standard deviation. Usually, this standard deviation, it measures that how the data isn't dispersed, okay, in the bell-shaped curve. So when you will see at the middle, okay, it is the mean, median will be the, and also mode will falls below this third quartiles. Next is the parametric and non-parametric analysis, very, very essential things for an analysis. What is this parametric statistical analysis? Usually what happens, okay, here we will draw the conclusions to the parameters of a normally distributed population. Usually it is an quantitative variables are normally distributed or analyzed within parametric test, okay, in the bell-shaped of a curve. Here, for going for a parametric test, okay, we assume that one, usually the data, okay, which specifies, okay, that the means of the sample group are normally distributed in the bell-shaped curve. The assumption of an equal variance, which specifies that the variances of the samples of their corresponding population are also equal, okay, and also the data usually is having a random sampling, okay, random samples. On these three things, we will go for a parametric test. Then is the non-parametric statistical analysis, okay. Usually what happens in things when other assumptions for a parametric will not meet, okay, on the time we will go for a non-parametric, okay. Non-parametric analysis is used in statistical testing when certain assumptions of the parametric test are not met, okay, or when data is normally distributed, okay, in the bell-shaped curve. On the time, we will go for a non-parametric test. Data is not normally distributed. Usually, the data is an ordinal or ranked data. When the sample size is very, very smaller, especially if it is below 30, okay, usually we will go for a non-parametric test. Homogeneity of a variance of assumption of a violation means non-parametric test do not require the assumption of an homogeneity of a variance, which is required for some of the parametric test. There are some of the things which is very outliers, okay. You have seen that one in the bell-shaped curve, okay. When it deviates more, okay, it is very, very lesser. This is known as an outliers. Non-parametric test can be more robust to the presence of an outliers compared to parametric test. Next is the categorical data. Non-parametrics are also used when the data is inherently categorical, okay. Means like frequencies are there, frequency counts or proportions are there. On the time we will go for a non-parametric test. So when you are going for an analysis, okay, it may be an exploratory data analysis, means you have to get to the nature of the data and search for hidden structures of an or models, okay, to explore more. For a confirmatory data analysis, you can go for an inferential statistics, then you can proceed for the sample. So what FFN test we have to choose it, okay? This is the model which you can use it. If you want to compare it to two groups are there, when you know the mean, okay, you can go for an parametric, for an independent two sample test. If it is an lesser samples are the non-parametric, like a man witness U test. If you want to go for a percentage, okay, you can go for a caste test. If you want to compare one group comparison, okay, mean, okay, single mean, if it is there, if you want to find out a mean differences, okay, you can go for a parametric test as a paired t test if it is in one sample. Non-parametric, if it is in one sample t test, okay, Then if the samples are lesser, on the time you can go for Wilcoxon signed scale test. If more than two groups comparison are there, okay, parametric, you can go for an ANOVA. This is the one-way ANOVA, two-way ANOVA, and multiple ANOVA, okay, because it depends upon your how many items are there in the groups, then how many you are comparing, okay. Next, non-parametric, you can go for crucial values test. Then to find out an percentage is the caste test. Today we will see some of the very important statistical tests like in student t-test, JET test, and ANOVA. Student test, of course, it is developed by W.S. Gossett. Here we will test the null hypothesis with there is no difference between the means of the two groups. Okay, this is the one of the criteria and assumption we will include. Then we will move forward solving the it. It may be in one sample t-test or independent two sample test if it is an unpaired two test, okay, and the paired t-test. One sample t-test to test if its sample mean, okay, differs significantly from a given population of the mean. On that time, we will go for an one sample t-test, okay. The mean of one sample is compared with the population of the mean. So on that time, t equals to x bar minus mu divided by s divided by under square root of an n. X is the sample mean, u usually the population mean, s is a standard deviation, and normal n is the sample size. So we can go for a think that on a random sample of having in 20, okay, from normal population gives a sample mean of 40. Standard deviation is in 6, okay. Then hypothesis population mean is the 44. On that time, you can go for a t-test. So on that time, you have to frame in first is the null hypothesis as well as an alternative hypothesis. For an wherever you are testing it, okay, you have to frame in null hypothesis. So H0, there is no significant difference between sample mean and the population mean. Then there is a significant difference, okay, as an alternative hypothesis. So you can, if when you put it, okay, t equals to mean is the 40, then mu is then 44, total is the 20, then standard deviation is the 6. It comes as a calculated value is in 2.981 and table value is in more. So calculated is more than the table value. So we reject an H0, okay, null hypothesis. Next one is the independent two sample t-test, also called the paired t-test, okay. If you want to test, okay, if the population means are estimated by two independent samples differ very significantly. Two different samples with the same mean at an initial point and compare at the end. T equals to x1 minus x2 divided by under square root of n square into 1 divided by n1 plus 1 divided by n2. This is the formula. You can put it, then you can go for an. Here you can use this one also for an extension where x1 minus x2 is the difference between a means of, if the two groups are there, then S is the standard deviation. When you put this one, for example, hemoglobin level of an 5 male, 10, 11, 12.5, 10.5, 12, 5. Okay, and females are in, because we are comparing, okay, male and female, 10. Like this, hemoglobin values are there. First and foremost, frame and null hypothesis, H0. There is no significant difference between the hemoglobin level between male and female. Then there is a significant difference between male and female hemoglobin values. So we can put this, apply this one, x1, x2, okay, x1 minus x1, then square, then x2 minus x2 whole square, okay. If you put this one, calculated is in 2.287, table value is in 2.306, okay. When you will see this one, T calculated is in more than that value, so you can reject the null hypothesis. Next one is the paired t-test. This is also very frequently we will use it, okay. If you want to test if the population means estimated by two dependent samples differ very significantly. On that time, we will go for a paired t-test. Usually when the measurements are made on the same subjects before and after treatment, okay, like in pre-test and post-test, on that time we will go for a paired t-test, okay. T equals to d dash divided by s into d divided by under square root of the n. D is the mean difference of the two groups. Then SD is the standard deviation of the differences, okay. So you know that on systolic BP of 5 patients, okay, before and after therapy, okay. Some any drug before is on 160, 150, 170, 130, 140. After is that. So we can have an here you can frame as an null hypothesis. There is no significant difference between BP level before and after administering the drug. Then as an alternative hypothesis, there is significant difference between BP before and after. So you can put it before, after. D, you have to find out the difference, okay. Then D minus D, then square, then it's summation, okay. So D equals to 22, SD is then 23.875. Calculated is in 2.060. Then table value, you will get the value in all the statistical tables or also in the computer, okay. And T calculated is lesser than the T table value, so you can accept the H naught. Next, very frequently used is the Z test. Generally, Z tests are used when we are having a larger sample size, more than 30 usually, okay. Where T tests are mostly if it is in the samples are in below 30, we'll go for a T test. Otherwise, if it is in more, then we'll go for a Z test. Both methods assumes a normal distribution of the data, but Z tests are more useful when the standard deviation is in you don't know. On that time, you can go for Z test. Z equals to X minus mu divided by underscore of an N. Next one is the very, very important and very widely used is the ANOVA, analysis of variance. It is discovered by R.A. Fisher. The student test cannot be used for comparison of an here, if more groups are there, especially for an T-test, it is in 2 groups, okay? But 3 and more are there. On that time, if you want to compare it, we need an ANOVA. The purpose of ANOVA is to test if there is any significant difference between the means of 2 or more groups, especially having in 3 or 4. The analysis of variance is the systematic algebraic procedure of decomposing the overall variation in the responses of an observed in an experiment into variation. So there are 2 variances, okay, between group items and within the group work, okay. In this time, we will go for an ANOVA. For an within group variability, it is called an error variance, is the variation that cannot be accounted for the study design. The between group, okay, or in what you call an effect variance is the result of the treatment. So for ANOVA, okay, you can go for an as an alternative is an F also. F statistics, F equals to MST divided by MSC. MST is the mean squares between the groups and MSC is the mean square between within the groups. Next is the non-parametric test. Usually we will include as a caste test, Wilcoxon sign rank test, Mann-Whitney's U test, then Kurzweil-Wallis test. Okay, caste test is also a very, very widely used one. Whenever the data is in categorical way to analyze it, we'll go for caste test. Okay. To know that on how the statistical decision making caste is needed, yes, discovered in 1900 by Carl Pearson. Also follows in Carl Pearson's formula. Okay, the chi-square test compares the frequencies and test whether the observed data differed significantly from the expected one. Okay, so we have to have in 2 as an observed one and expected the difference. Okay, so you can go for a chi-square test. Chi-square equals to usually this denoted by like this sigma O minus E whole square divided by O. Groups are there, attacked or non-attacked, vaccinated or non-vaccinated. Okay, this is the, if you want to measure it, okay, so frame in a null hypothesis that there is no significant association between vaccination and attack of a measles. Okay, then there is a significant association as an alternative. So what is an observed and expected? Chi-square equals to sigma O minus E whole square divided by O. So OI, the items 10, 90, 26, 74, EI expected is an 18, 82, 18, 22, OI minus EI, then whole square, then it's summation. Okay, so chi-square table value is in 3.841 and calculated is in 8.672. So calculated is more than the table value, so we are rejecting the null hypothesis, rejecting H0. Next test is the Wilcoxon signed rank test. Okay, here Wilcoxon signed rank test is a non-parametric test. to see that whether there is a significant difference between the paired observations too. Okay, paired data we need. Okay, for each observation in one group paired with the related observation in the another group. Okay, and it has to follow normal distribution in the normality curve, having an ordinal data, and also in a speed data. When the distribution of the differences between paired observations is skewed, okay, somewhere it is an altered. Okay, the signed rank test can be more suitable than the parametric test. Okay, this is the one of the point you have to keep it in mind, and also the sample size is below 30. Outliers, you will come to know that when you will put in a graph, you will come to know that so many data is out of the track. Okay, the test is less sensitive to outliers compared to the parametric test, making it a good choice when you suspect the presence of an outliers in your data. Next, if it is having an interval data, okay, with concerns about a normality, even if your data is on an interval scale also, if you have concerns about the normality of the differences between paired observations, you can go for a viscosum signed test also. Okay, remember that it is very, very robust, and don't assume the normality. Okay, you cannot hold that homogeneity will be seen in the, as such that in other test as in the bell-shaped curve. It may have less statistical power compared to the parametric test when the assumptions of the latter are met. Therefore, the choice of the test should be based on the nature